Now let's put our hands into a clay and actually make a Modbus test by using a computer, service cable, and a probe. And here I actually have a probe that is capable of communicating with Modbus and a service cable. And what is special about this service cable is that this USB port will provide the power for the probe and also work as a RS-485 USB converter. So typically, if I want to change some settings in this probe, I will use the Vaisala Inside PC software, but this cable can be also used for testing Modbus communication. And let's take a look how to do that. And as I mentioned, all these Modbus registers and communication parameters are more or less vendor specific. And that's why you need to keep this user guide open when you start testing Modbus communication. I will use a command line tool called Modpol. You can install it from the web. I can add the link in the webinar material as well. And by typing Modbus and H, I will get the help where all the comments that I need are presented. So Modpol. And first I need to define what kind of protocol I'm using, and I'm using RTU. Then I need to know what is the unique address of this probe, and the manual says that it's 240 by default. And then I need to take care that the communication parameters are in my PC, which works as a Modbus master, are the same as the probe. So serial bitrate is the 19200 by default in both systems. Data bits are 8, that's also correct, but the stop bits are different. So I need to define in the Modpol that I use 2 stop bits, and the parity is also different. HMP 113 defines that it's none. Then I want to read some measurements. I want to read relative humidity and temperature. These are now floating point values. And the first register is 1. And Modpol is actually using 1-based registers. So that's why it's 1. And then what I'm actually reading here is data registers. I will use this T4, and these are actually float values. So we don't need to take care of the endians or byte orders or stuff like that. This Modpol works by default correctly. And actually I need to read 2 registers because I want to read the temperature as well. So number of values 2. Okay, Modpol is a little bit special in this sense that I have defined float, and Modpol knows that float occupies 2 registers. So actually, if I want to read 2 float registers, Modpol will automatically read 4 16-bit registers. And the last important thing to know is the virtual comport that this computer is giving to my USB service cable. And let's hit enter and see what happens. And there we have. The first reading is now relative humidity and second reading is temperature. Okay, quite close to each other. How will I know which one is which? So one way is to just provide some humidity here. And this also demonstrates that this is actually live reading that we get from the probe.